Moving ahead, let's have a more refinement, more ideas, more deep dive as far as the crust or as far as the interior of our earth is concerned. The first one is crust. So crust is the topmost part of our earth's surface on which we used to live, on which you see water bodies, on which you will see vegetation, on which you will see roads, on which you will see rivers. So crust is basically a thin, solid, rocky, outermost layer of our earth on which no one life exists. This is the image here. You can see the part where we have a continents, that will be called as continental crust. The part where we have an ocean, that will be called as what? Oceanic. Simple. Okay. Now, what could be the thickness? What could be the depth of crust? So the depth of crust is from surface till 100 kilometer. So from surface till 100 kilometer, we will have what? Depth of crust. And one more thing I want to mention, that the depth of this crust is highly uneven, that it is ranging from almost 3 kilometer in some areas of the world up to 120 kilometer in some areas of world. Somewhere we have a, we can say we have a thick continental crust, whereas some areas where we can have thin continental. Okay, so continental crust used to vary. We are just giving a average depth, and that average depth is what? From 0 to 100. So from 0 to 100 kilometer we have what? Crust. So in some areas of the world you will see crust at 4 kilometer. That is only the thickness of crust. Somewhere in world you will see the crust is basically thick beyond 50 kilometer, and somewhere you will see the crust is thick beyond 100 kilometer. So thickness is also uneven. Thickness is not uniformly distributed, especially in, or let's say with respect to interior of our earth as far as the crust is concerned. So crust is highly uneven. In geography everything is uneven. Okay, everything is uneven. If there is a evenness in geography, this would have been a science. That's why geography is a humanities subject, not a science subject. Logics are there, but still it used to be studied in humanities. It's because there is some sort of exception. That's why. And this is one of the example of exception. Continental crust is there, and based on that particular pattern of densities of rocks and all, we have a one particular category of densities of rocks extended from 0 to 100 kilometer, but not in uniform manner. Somewhere it is thick, somewhere it is thin. Okay, so crust varies from 3 to 4 kilometer depth to 100 to 120 kilometer depth. For reference, you can go with this. So crust will have a depth which is 0 to 100. So from surface, if you move towards the 100 kilometer depth in our interior, that would be the part of crust. Crust is comprised of two sets, continental crust and oceanic crust. If you see the continental crust, so continental crust is basically more thick as compared to the oceanic one. Okay, oceanic one is comparatively thin, comparatively with respect to the continental one. So if you see continental crust, so continental crust is basically thicker and less dense than the oceanic crust. It is thick, it is wide, and oceanic crust is what? Thinner. It is thinner, but ocean have to carry weight of water. Okay, and it has to be what? Denser. So as ocean is carrying the weight of water, so what we can say that the ocean crust is more dense. Ocean crust is more dense as compared to continental. Okay, density if we come, and continental crust is more thicker and oceanic crust is thinner. If we see continental crust, so as the continental crust is less dense, that means what? That it is comprised of light color silica rich, which is used to referred as felsic. felsic rock, and that is comprised of granite. So continental crust is primarily or majorly comprised of granitic rock. Granitic rocks are there, and these granitic rocks are featured with more silica content. And when we have a more silica content, or let's say silica, that sand which we used to see, that is one of the resemblance of silica, we can say. So when we have a more silica content, that particular rock would be referred as what? That would be referred as felsic. And such rocks will be light colored. So if you see continental crust, so continental crust is light colored. That continental crust is comprised of felsic kind of rocks and granitic rocks. Whereas contrastingly, if you see the continental crust, so continental crust is comprised of what? It is comprised of iron and magnesium rich rocks, and iron and magnesium rich rocks are basically known as mafic. Are being known as what? Mafic. Okay, and these mafic are being called as what? Basalt. So basalt is also one of the rock which is being found in the oceanic crust, and basalt is more dense, whereas granite is less dense. Granite is found in the continental crust, whereas basalt is found in oceanic crust. So this is an idea with respect, this is what an idea regarding Earth's interior, specifically the crust, you can say. Moving ahead, here if you see, we have a one word which has been used. So from surface till the depth of 100 kilometer, we have what? Crust. What? Then here you will see that we have a one part which is called as what? Lithosphere. Now lithosphere is basically comprised of, see, beyond crust we have what? Mantle. So lithosphere is actually comprised of entire crust. Okay, is comprised of entire crust and upper mantle. Here we can say upper mantle, here we can say middle mantle, and we can say lower mantle. The further categorization of these layers, geologists used to further categorize. Okay, and even in the upper we have a one more classification: upper mantle, upper lower mantle, likewise. So when we have a crust and upper mantle part, so this is being known as what? Lithosphere. Being known as what? Lithosphere. And the depth of lithosphere, you will see that the depth of lithosphere is up to 200 kilometer. Okay, 200 kilometer. At that depth you will see lithosphere. And yes, lithosphere is also highly uneven in our interior. Somewhere you will see that lithosphere is shallower with respect to the earth's surface. Somewhere you will see that lithosphere is deeper with respect to the earth's surface. Somewhere lithosphere is there at the depth of 200 kilometers. Somewhere lithosphere is there at the depth of even 300 kilometers. So this is the average depth of lithosphere. So lithosphere is basically Earth's rigid outer layer, and its thickness varies from 10 to almost 200 kilometers. In geography, nothing exact is there. There is nothing exact when it comes to the numbers. Whereas in science, we have data, we have quantitative relations, we have exactness. In geography, we have logics, but there is no exactness. That's why it is actually being a humanities subject rather than science subject. And this particular lithosphere, I told you, is comprised of entire crust and upper part of solid mantle. So what we can say, lithosphere is what? Lithosphere is basically solid. Okay, it is solid. Now if I ask you, the rocks which are there in crust and the rocks which are there in the upper mantle, whose density would be greater? The density of rocks which are there in the upper mantle, their density will be greater, as compared to the rocks which are there in the crust. Because I hope you remember that universal aspect, that when you are moving from the center, when you are moving from the surface towards the center, density will increase. Simple. So from the crust towards the mantle, if you are moving, density of rocks will increase, and this has been justified by the various theories, and we have certain evidence. Kola super hole, yeah, Kola super deep hole, I hope you remember that one. So this is about the lithosphere. Moving ahead, after lithosphere we have a asthenosphere. What is asthenosphere? Asthenosphere is lying below lithosphere. Again we have a crust. We have what? Crust first. After the crust we have mantle. The depth of crust is up to 100 kilometer, and the depth of lithosphere is up to 200 kilometer generally. Okay, and here in the mantle itself we have a one specially transition zone. In the mantle itself we have a one specialized transition zone, and this transition zone is being known as asthenosphere. So here we have a mantle, here we have a upper mantle, and this upper mantle and crust is a part of lithosphere. This crust and upper mantle is a part of lithosphere. So what we can say, that this entire lithosphere is actually on this upper mantle part, or let's say upper middle mantle part, and this upper middle mantle part is basically asthenosphere. Now what? Asthenosphere. Here you can see. So this is what the part of lithosphere. Okay, lithosphere is comprised of crust and upper mantle, and this is what the asthenosphere. Asthenosphere is also extending up to the depth of 80 to 200 kilometer deep. Sometimes it is 350 kilometer deep as well. Okay, so this rigid lithosphere can easily float on asthenosphere. That means the nature of asthenosphere is different. Yes, the nature of asthenosphere is different. The asthenosphere is a soft, asthenosphere is like a plastic. It is not liquid, it is not proper solid, it is like plastic. Plastic, I hope you remember that if I try to bend it, it will bend without losing its integrity. Okay, without losing its uniformness, I would say, and it act like a solid rock, let's say. So asthenosphere is like plastic in nature, subjected to, we can say, bending while maintain the same structural properties. So we have a plastic nature, and this plastic nature is there with the asthenosphere. It is brittle and ductile, and the density simple. The pattern of density is simple. The pattern of density is what? That when you are moving in this way, density would going to increase. So here we also have a same density pattern. So crust will have a density, then if I include the upper mantle, that will also have a density, and this asthenosphere will also have a density. So the density of the asthenosphere is higher than the crust. Simple, based on that same pattern, the behavior from the surface towards the interior parts. During volcanic eruption, this asthenosphere is act like a source of magma. Okay, it act like a source of magma. So what we can say, that this lithosphere is actually divided into number of different plates, or which we are referring as what? Lithospheric plate. And these lithospheric plates are keep on floating on asthenosphere. So again, let me summarize it for you. Now, let me summarize. So, crust would have crust is there, and crust is the topmost layer. Crust would have a depth up to 100 kilometer, highly uneven depth is there. After the crust, we have what? We have lithosphere. I mean, technically, after the crust, we have a mantle. So, here, crust including upper part of mantle. This is what the upper part of mantle. This part is being known as what? Lithosphere. What? Lithosphere. Crust as well as the upper part of mantle. And when we add this mantle in certain layers, let's say upper layer, middle layer, and lower layer, or let's say upper mantle, middle mantle, and lower mantle. So here, after the lithosphere, in the mantle itself, we have a one transition zone, and that transition zone is what? Asthenosphere. The depth of asthenosphere is up to 350 kilometer from the surface. Okay, so this is what a general idea about the interior. Moving ahead,